All right, folks, we'll kick things off. I don't have much to add in terms of announcements. You'll be hearing from me a little bit later in the day. The way we are going to run this session is 3 talks, 1 hour, 15 minutes for the presenter, 5 minutes of Q&A. And whoever is presenting Bob here will kindly disagree to show you the 2-minute, 5-minute type of work. And we'll leave all the questions for the end of the okay. All right. With that, we'll kick it off. The first research talk of the workshop, Anil Doshi is going to talk to us about Gen AI and strategic decisions.
Thank you, Karthik. Thank you very much. Good morning, everyone. First of all, thanks very much to the organizers for including our presentation in the schedule today. Very excited to be the opening of the session. I don't think that's an indication of the paper, but I'm excited to open it nonetheless. My name is Anil Doshi. I'm faculty at the University College London, UCL School of Management. I'm going to be presenting research today with colleagues Bart Van Est and Emil Mirzayev, also at UCL with me, along with Jason Bell at Oxford. So just before I start, this is a different kind of conference. I just want to get a brief sense of kind of if you can raise your hand if you are in industry, kind of like working in management, and folks who are research academics. Okay, cool. So if I didn't get your category, I apologize. I just want to get a sense for the mix. Okay. So I'm presenting research today considering what it means to use artificial evaluators to understand a business decision. So I'm faculty in the strategy group at UCL, and we spend a lot of time thinking about strategic decisions. And so you can think about the characteristics of a strategic decision. They're kind of fraught with uncertainty, right? They often relate to a future state of the world, which is never fully knowable. And therefore, when you're making a strategic decision, which is typically complex and highly interdependent, we have to worry about kind of the irreversibility of some of the decisions we make, along with the commitment we have to make to those decisions, which makes it quite costly to undo a strategic decision. And so we have this notion of the importance of strategic foresight, right? What can we evaluate today before we have to make our decision and see it implemented tomorrow? And we can think of this in a lot of different contexts. I'll be talking about it in the context of business models, but you can imagine it relates to, your business development, and you're thinking about which acquisition to make, or which investment in your R&D portfolio to pursue. And so we see lots of different kinds of strategic evaluations. And up until very recently, we thought about, well, how do we get information? Well, we get information from people. We think about humans as providing these evaluations, but now we can think about artificial evaluators as well. And so this project is going to take seriously this idea of wanting strategic foresight in the context of business models, looking at artificial evaluators. And the motivation of the project, the research question we want to look at is, how can artificial evaluators gain traction on some kind of strategic decision? Okay, so just a little bit of kind of setup on how we thought about our research. We can think of different ways in which we get information on some kind of strategic decision. And this is very much like along the lines of the wisdom of the crowds type of work that you might be familiar with. We can get information from individuals, we can get information from experts, we can throw them into a crowd together and do some kind of averaging and get some average mix of that opinion as well. Well, we're going to take that idea and use it with artificial evaluators. And we're going to borrow kind of some of the foundational thinking in the crowds literature, in that if the errors aren't systematically biased in one way, that we can average across multiple evaluators and get a better prediction. Okay, so that begs the question, what makes us think that generative AI or large language models can give us these kinds of predictions? Well, large language models in some way are representations of language. And so if we're going to give it a question about a strategic decision, the input is the content of the decision, and the output is its evaluation of that decision. It becomes a fairly straightforward process relative to some prior models like supervised learning, where you needed training data, you needed large samples, and things like that. And we see large language models being used in prediction in various flavors, right? Answering questions, categorizing texts, and which we are going to use that kind of model, that setup, to understand evaluations of a strategic decision. Okay, so we're going to do two studies. We have done two studies. One is going to be using business models generated by a large language model. That's kind of for internal validity. It allows us to control the content of the models, and we know from other research that kind of the tone of a presentation might affect an evaluation. So we're trying to strip out a lot of the other factors that might go into an evaluation of a business model, and we have generative AI generating several business models, and we're going to use that for internal validity, right? Like we control the environment. But we also do the second study where we take business models from a competition that occurred at a large university. These entrants into this competition were vying for about $1 million in prize money, so it's kind of external validity, right? This is also useful in the real world as well. Okay. So I'm going to focus on the first business model. I'm just going to preview the results a little bit. We see a significant amount of consistency across the two studies. So I'm going to focus on the first business model to have you think about the structure and the setup of the study, and then we'll talk about the results across the two studies. So what we do is we generate 60 business models using GPT-4, ChatGPT. We have it create business models across 10 industries. And we have it generate using two different prompting styles, right? Just like write a business model or have it use chain of thought where we ask it to consider customers, and with that kind of customer, what kind of service would you offer? And with that service, what kind of activities would you need to assemble around an organization? So we have two ways of getting the models. And then just to create some variation in the types of models, we ask the ChatGPT, we ask the GPT to give us a model with a high, medium, and low probability of success. Now, we don't know if, in fact, these have high, medium, and low probability. It's just to generate variation in the models. And the mean number of words in a business model is 83 words in a model. So here's kind of a sense for what the business models look like and how we structure the problem for our evaluators. We give two business models to the evaluator, and we ask the evaluator which model is more likely to succeed. So you have to pick A or B. And you can see these are fairly short when you look at the business models. And so who are going to be those evaluators? Well, first, we ask a series of human experts. And who would we ask for that? We surveyed a set of 100 strategy scholars that we in our network. And so I'm not sure if anyone in this room was one of those folks, but if you were, thank you very much for helping us with our study. We have, you can see the demographics of the people we polled there. Of the 100 people we asked, we got 51 responses. We asked each respondent to provide 10 pairwise evaluations. So we've had 510 evaluations from our benchmark human experts. We also wanted a baseline, so we asked kind of everyday users of Prolific, which is an online research platform, to provide evaluations as well. We only asked them for 3 so as not to create fatigue, and we got a total of 408 evaluations, pairwise evaluations from that group. And then obviously we asked our generative AI. So how do we structure the query to generative AI? We use 7 different LLMs. We ask it to play one of 10 different roles. So for example, you are a customer of this kind of business, or you are a journalist or a politician and the like. So kind of some kind of internal or external stakeholder. And then we have it evaluate using 2 different prompting approaches. Again, a base prompt where you just choose, or we ask it to reason through its choice in a chain of thought. And obviously with LLMs, they don't get tired, so we can ask the entire set of pairwise evaluations to each LLM role prompt set. And so we have 37,000 plus evaluations from our LLMs. Okay, so what do we get from that? So imagine that we have a series of the LLM role prompts, and we have all of the evaluations from those LLM role prompt series. How do they do when you just look at them individually? Well, it turns out individually they don't do very well. They're quite inconsistent. What does that mean? That means if you say, which business model do you like better, A or B? And it says A. And then you say, which business model do you like better, B or A? It'll say B. And so the inconsistency arises from some kind of order preference. And so the left-hand side here shows you this level of consistency in its response. And the right-hand side shows you the extent to which it has a preference for the first or second choice. That bias leads to that inconsistency. And I think that comports with a lot of people's use of their kind of everyday use of LLMs. Oh, I asked it for, I talked to an executive. They said, well, I asked it for like some business strategy ideas, and it came out with rubbish. Yes, of course it did. That's consistent with what we find in our results when you look at an individual LLM role prompt. Okay, well, we can aggregate these evaluations now. And so the first way we aggregate is by this set of LLM role prompts. And so we have a series of 130 of these evaluators, and we can see how these correlate to the evaluations of the strategy experts. And what we see here is they start looking like the evaluations of experts. So what we have here is 4 different measures of correlation. Correlation of the proportion of times the business model was chosen, the correlation of the ranks in the top right, how often a business model was picked as the best, and how often it was picked as the worst. And the yellow bar is the human non-experts, and the blue bar is the uniform evaluators. And so with our uniform evaluators, we see that they're already performing a little bit closer to the human experts. Well, we don't have to keep them set into their own silos of LLM role prompts. We can mix it up. And so we can randomly draw evaluations across LLM role prompts. And we see when we do that, we get a little bit better, a little bit closer to the human experts. And then we can put them all together in one big bucket, which we call our comprehensive evaluator. And that comprehensive evaluator, again, looks even more closely like the human experts. Okay? So our second study was, as I said earlier, had to do with a business model competition. We tried to mirror study 1 as close as we could. I'm going to skip the details of the study design a little bit, but you can see here the mean number of words is 2,000, significantly larger than what we showed in our first study. And we only have the experts here, which were the judges in the competition itself. And then we have an LLM role prompt series as well. We dropped some for various constraints because of the windows. So I'm going to just briefly show you that, as I mentioned earlier, the results are fairly consistent across the 2 studies. We see the similar types of inconsistency, and we see better correlation with the experts as you use these different kind of evaluators, the uniform, the mixed, and the comprehensive. That vertical dashed line in each of the 4 is the best performance from study 1. So you can see sometimes we get close, sometimes we're overperforming study 1, sometimes we're underperforming study 1. But overall, we see this general consistency in looking like the evaluations of human experts. And so just to conclude, we are taking a first step in the study and thinking about what it means to have like an AI strategist. And so by no means are we saying we have like a full representation of human judgment, but in this way, in the way we've kind of structured this evaluation and aggregation, we can start looking more like the human evaluations. And we also show in the paper in much more detail that I briefly described here, the extent to which diversifying in the mixed evaluators derives greater approximation to the human experts versus aggregation by throwing them all together in the comprehensive AI evaluator, and these different ways of improving the aggregations. So that's it for my talk. With that, I will take some questions now, right? Okay, great. Thank you very much.
You guys have questions? This is being recorded, and we definitely want to hear your voices.
Yes, sorry, Karthik.
I think she wants me to wait.
Oh, Mike, yeah, we're going to mic you up. Yeah, sorry.
So this is really interesting. It reminds me of a paper which is called "More Agents is All You Need." And essentially the point of that paper is when you're trying to make a hard judgment or getting AI to do something hard, then just throw multiple AI doing the exact same thing, and then aggregation, it does better. And in fact, I have a startup where we use AI to evaluate the output of AI because it's very hard to evaluate text output. Is this good or not? We've seen something similar that if you aggregate them, then they start to do better. One question for you over here is that I'm kind of curious about is there any value in terms of the diversity of opinions, or you've seen any patterns in terms of what one gains by aggregating many opinions? And is there a sense in which certain things is there new information emerging from the aggregation?
Yeah, so the first thing is we created our variation in 3 different ways, right? We had different LLMs, we asked it to take different roles, and we have 2 different prompting approaches. By no means is that the only ways of introducing variation in the prompts. And I think I have the slide here. Yes. So we didn't do a kind of did ChatGPT do better than Gemini kind of study. That wasn't our purpose. But we have these different kinds of aggregations here, right? You can hold constant the LLMs and mix up the roles in the prompts, or you can do one or the other, or you can mix up 2 and keep the third one constant. And you can see here that we do find at least different types of improvements across the different types of evaluators, depending on what you're holding fixed and what you're varying. So yes, the different types of diversification does bring different benefits. And I would speculate that if you introduce even more kinds of variation, you might get more wisdom of the crowds.
Sorry.
Oh, sorry, I didn't realize. Sorry, what's your name?
You.
Hi, you.
Nice to meet you. A very good talk. I just have a question. So I was wondering, so like you said, right, there's, you talk to executives and you said for individual like outputs, usually they're not that great. So I was wondering, is there a perspective of human in the loop sort of LLM in the sense that you sequentially have either human inputs and then you have, say, GPT inputs? And somehow, by organizing it in a certain nice framework, that particular aggregated decision is the most optimal that you can get. So in a way, human decisions are being augmented by the AI decisions and vice versa, right? In that sort of sequential decision framework.
Yeah, so I'm as soon as we get off, as soon as I'm stopping, I'm going to write that down as an interesting idea for future research. We definitely, our starting point was thinking about the LLMs themselves. Again, I think this is along the lines of my response to Karthik's question. There's no reason to suggest that this is the only way of approaching making an evaluation. So the human in the loop, the extent to which it's autonomously making decisions versus us giving us our feedback or adding information or even providing kind of like, here's a rubric on how to make a strategic evaluation. There's lots of different ways to improve it, either in the instructions to the LLMs or the ways we talk about integrating them, or in the kind of the process to come up with that evaluation A or B. That's a great idea.
I have a loud voice, that helps.
We just want to make sure we get your loud voice.
Save time. This is on.
Yes, it's on.
Thank you, Anil. Very intriguing research. I wanted to throw a bit of light on the roles. Why 10? Does it matter, the number? And did you go internal roles or external?
Yeah, good. What's your name? Sorry?
Sajeev.
Sajeev, thank you for your question, Sajeev. So 10, because we wanted sufficient diversification of different types of evaluator approaches. There's no reason it should be 10. I'm not going to be able to do this on the fly, but we can think about when we fix the different kinds of roles. So 10 was arbitrary. It might be that 12 or 15 works better. We did have a variety of internal and external roles, kind of you are an executive in the business, or you are a politician, or you are a journalist. So we did have both types within the roles.
So, yeah, we have time for like one more question, so short.
Anil, since I'm allowed, I'm intrigued by a choice of political journalist. Like as an industry person, I would think external means my suppliers, people external to my industry. Okay. And internal would mean roles within my company.
Yeah, so fair enough. I conflated what I mean by internal and external. Internal, I meant like in the industry. And external, I meant like external stakeholders that might have a vested interest in thinking about these kinds of questions. So when I say politician, I mean like a policymaker, a regulator.
Yeah, the same remark as he made. What I'm taking away from the research is that more agents better, agree, and more roles better.
So we didn't test for like if there's a marginal increase improvements in certain scales of these different dimensions that we look at. We just show that it does improve with our scope that we imposed on it. So, but diminishing returns is probably something you want to be thinking about.
One last question? Okay.
Great. Thank you very much.